Hello everyone, and welcome back to the Literacy Volunteers of Harrison County YouTube channel. We're a nonprofit United Way agency. We would love for you to like our videos, but more importantly, we'd love for you to subscribe to our channel. We're trying to get to 150 subscribers by the end of summer, and we would love for you to hit that bell icon below, and every time that we put out a new video, you will be alerted to the fact that it's out there, and share them with all your friends and family. We just looked at a video on simple machines, so if you'd like to go back and check that one out before you do this one, that might be advantageous. We're going to look at energy in this video. Still simple physics, but energy. What is energy, right? It's the ability to do work. We just talked about work in the last video. Work is force times distance, right? So it's the ability of you to use a force to move an object, yourself, something, a certain distance, right? Modern civilization is possible because people have learned how to change energy from one form to another and then use it to do work, right? I've given you some examples here, 7 examples of what you might use energy to do. You might use energy to walk, run, ride a bicycle. All of those you use energy. You might use energy through your car as it's moved along the road, or boats as they're moved through the water. When you cook food on your stove, that you're using energy. When you make ice in the freezer, when you light your home, your office, any place you go that has lights. When you manufacture products, when we make products, and even when we send astronauts into space. All of those things we're using energy. We're changing energy from one form to another. Here are the forms of energy: heat, light, motion. Then we have electrical energy, chemical energy, and what's called gravitational energy. Those forms are grouped into 2 general categories, which we'll look at specifically here in a moment. The 2 big categories are potential, right? That's stored energy. Someone says you have a lot of potential. What they're saying is there's something in you that they know looks good, or that will be able to do work, or that will succeed. That's your potential. That's energy we're storing, things, qualities you might store. And then we have kinetic, and kinetic means to move. That's our working energy, right? Our kinetic energy. Energy can be converted from one form to another. I just gave us this example because we're pretty much familiar with coal. And within coal, there's stored energy. That's potential, right? It's in there. And then that energy is changed to chemical energy. When we convert that, when we start to burn it, then we take those chemicals to light our home. So then it's converted into electrical energy. So we're just changing forms of energy here. Can you think of another example where you've changed energy? What about boiling water? When you put water in a pan, and how does water boil? How do you know it's boiling without sticking a thermometer in there? You see all those bubbles coming up. Essentially what you're doing is taking and adding energy to the water molecules, and the more energy they get, the faster they move. Not more faster. The faster they move, and they start to jump around, right? And then they start to cause the water to boil. Once they get enough energy, they leave the surface as steam, right? So we're just adding energy into that situation. You could think of 100 examples, I'm sure, of energy. Sorry. Sources of energy. We have these 2 sources. We have what's called renewable energy, and that's energy that can be replenished. If you're going to go for a walk or a run, you may be able to run a mile, go home, right? Rest, maybe eat, then you can go run another mile. That's renewable energy. It can be replaced. We also have what's called non-renewable, and non means not, right? So this is energy that cannot be replenished. Once it's gone forever. So renewable energy is useful energy collected from resources that are naturally replenished on a human time scale, meaning during someone's lifetime, right? We have carbon neutral sources. Sunlight is a carbon neutral source, wind, rain, tides, waves, and what's called geothermal heat. Those are all renewable types of energy. The non-renewable ones are the ones we can't get back once we use, like coal and natural gas, oil, or even nuclear energy when they're splitting those atoms, right? Once these resources are used up, they cannot be replaced. And that's a big problem for humanity, because we're currently dependent upon these sources, and once the supply runs out, then what happens to humanity? Excuse me, I'm going to get a quick drink. The next lesson that we do here on the channel is going to be on these resources. The greenhouse effect, right, and global warming. So let's check out the next page. I told you we would get back to the potential and the kinetic. I'm sorry, I just got water on that. Potential energy. An object can store energy as the result of its position. Here's a crane, and it has the wrecking ball attached to the crane. When that ball is pulled back and it's no longer moving, the energy is stored in it, here in its elevated position. That's potential energy, right? When we let that ball go and it moves from here, and up, that's kinetic, because it's moving, right? An object that has motion, whether that motion is vertical or horizontal, has kinetic energy. So here it's potential. It starts to move, kinetic. It'll stop for a millisecond. That's all potential again. Kinetic. As long as it's moving, it's kinetic. This energy is what's called translational kinetic energy, and it depends upon two variables: the mass of the object, right, and the speed of that object, or the velocity of that object. Because kinetic energy is 1/2 the mass times the velocity squared of this object. That's our equation for kinetic energy, right? Gravitational potential energy, and we're going to abbreviate it GPE, is the energy stored in an object as the result of its vertical or horizontal position, right? It's vertical position or its height. The energy is stored as the result of the gravitational attraction of the Earth for the object. We all know about gravity, right? If gravity wasn't holding you down, or anything down, it would just float off into space. So that's a force that's pushing down on you. We looked at forces in the previous video. There's a direct relationship that exists between this gravitational potential energy and the mass of that object. So the more massive an object is, they're going to have greater gravitational potential energy. If we had a 1,000-ton block here, it's going to have more gravitational potential energy than a 1-kilogram rock because of that force. There's also a direct relationship between gravitational potential energy and the height of that object, right? The higher the object is elevated, the greater that gravitational potential energy is. So our equation is mass times g times height. Mass, m, would be equal to mass of the object. H is the height of the object. And this g here is what we call the gravitational field strength. And that's 9.8 newtons per gram on Earth. A lot of people call that the acceleration of gravity. If we went to the top of the Empire State Building and we dropped the penny, and we dropped the feather, and we dropped the bowling ball, those are all going to fall at 9.8 meters per second squared. Anything falls because that's our gravitational potential energy to Earth. Lastly, let's look at an example just so you kind of understand. So we're going to try to determine the gravitational potential energy of the object. The first thing we need to do is to make something zero height. Typically, we're going to use the ground as 0, right? We're going to arbitrarily select the ground. So here's the ground. Then I have this building, and I have a ball sitting on top of this building with a mass of 2 kilograms. I arbitrarily think this building is 6,000 meters tall. So our potential energy, we take the mass of 2 kilograms of the ball, 9.8 newtons per kilogram, that's our G, our gravity, and 6,000 meters this ball is up in the air. So our potential energy is 117,600 joules, right? That's our unit of energy. So when we're looking at this, let's kind of do a practical application. Why would you weigh more on Earth than you would on the moon, right? You're you. So if you're here or on the moon, you're not changing. What's changing here is your weight, and your weight is just your mass times gravity, right? So we